Hi. All right, let us start sharing the screen. Let us give you the link that you need. So here is the screen. That is the webinar or the seminar that we have. So I'm giving you that link on chat. Here it is on chat. That's our webinar, and I will call it like this. I'll say our webinar, and then give the link. And again, I gave it to one person. I'm giving it to everybody. So now if you guys click on that, you will see the same thing that I see here. And for those who are the first time here, I'll tell you that we're talking about AI and all kinds of interesting things there. The webinar link is new. Let's try that. What is it? Well, it's very strange. I don't understand that. So I'm removing that. I probably got in here by mistake. I don't think it's the hackers trying to lure us away. But that is the webinar folder. And I have something to put in there. All of the materials that we use, they are found right here. So if you can open that, you'll see that. That is the learning path. And every time there is an interesting new course out there, I'm putting it here. By now, it's about 2025, mostly from Andrew Ng. So I'm very grateful to him for that. And I think not only most, but all of them are free. That is how it is right now. And let's go. What we will cover today is one of the new courses, by the way. It's here. It's the new course, Built-in Applications with Vector Databases. We'll talk about this. We will also look at the Pinecone being a vector database, new capabilities, and a very interesting new thing. I'll talk about that later. Also, some practical things. I will show you what it is. There you are, back to the video. So, unless I see something on the chat requiring immediate attention, I'm starting. Well, those first two things, the Pinecone new capabilities, the announcement from the guys, and the building applications with the vector databases, they are related. Because in fact, let's open this course. And when I open it, I really want you to hear. So what I will do is stop share, share again, this time with the sound. So if there is anything to hear, you will hear that too. So let's go. Okay. Oh, that is now moving that window. That's the one. That's the link. So I'm out of order. That's okay. Starting right here. That's the course. Now, that course right here is from Tim Tully, who is one of the honchos at Pinecone. Pinecone being a vector database, and we'll talk more about that vector databases today. So the course is under Andrew Ng. Therefore, let's start for a few minutes.
Welcome to this short course, Building Applications with Vector Databases, built in partnership with Pinecone. Vector databases have become a key part of the infrastructure stack for building applications with large language models, specifically RAG or Retrieval Augmented Generation. But it turns out that they're useful for even more applications than is widely appreciated. In this course, you learn how to use vector DBs to quickly build applications in text similarity search, RAG, image similarity search, anomaly detection, recommender systems, and hybrid search, which refers to using simultaneously sparse and dense vectors. I know that's a lot of stuff, but that's why I hope you find this course useful.
Exactly. That's what I wanted to come to. I know that is a lot of stuff. That is really a lot of stuff, but I went through that course and I will show you today the major things that they will talk about. It would take you, my estimate, about an hour to listen to all the lectures, maybe less, because each one is about 10 minutes. Well, if you want to really gain useful information out of there, you will have to download the notebooks. So if you go to the next one, for example, and ask it to start.
Semantic search is a type.
So the minute it starts, it shows up the notebook. I showed you that you can simply download a notebook like this, export, download as notebook there. And if you put it into Jupyter right away, it will not work. That's to be expected. All these things are for the demo that should work perfectly, and you can run it inside of there, here, inside of the environment. So here, I'm checking that these imports are there, they are in the environment, and then it really works. They are. But if you download that and put it in your environment, it will not work. So you will have to spend half an hour to find out all the problems. There was one trick that they showed. If you say file and file say open, then you will see all of their additional files. For example, if you are missing this utility, that's where you get it. If you are missing those requirements, that's where you get it. Even so, it's not guaranteed to work this way. So you'll have to use some time here. But now what it is about and why would you listen to it? Well, what it is about those subjects that Andrew Ng said, that's a lot. But briefly, I'll tell you what they are, and I will tell you also how that really humiliated me to no end. Kind of, I was wiped out as somebody who knows anything. And here's why. First of all, they talk about semantic search. That means that it's our search. We're used to search. That's kind of Google search, that's Lucene search. There is syntax to that. But semantic search is where you search for the meaning and not for the keywords. Now, of course, it's easier said than done. That's an invention that's called word2vec. 2013 is when it was, and that was the state of the art then. And you're bringing this state of the art then to today. So it doesn't work perfectly. One of the things that it doesn't know is your background. What are you coming with? That's what Google always tries to find out about you. What do you already know, and what do I teach you next? But semantic search is one first step. The next step is, to that semantic search, you can add your own documents. Well, that's what I do in many projects. That's called RAG, Retrieval Augmented Generation. A non-descriptive term, but it's a standard architecture. You use this semantic search together with ChatGPT. It's interesting that based on that, you can do all kinds of tricks. Recommenders. What does he mean, recommenders? That means that he learns from the existing articles and recommends me what to read. Usually recommenders, these guys, they are, you want these products and you would want to buy these based on somebody who is similar to you. So his recommenders are not exactly like that, but kind of smart search. Which brings us to hybrid search. And here's what that is. That was one of the discoveries for me. Well, the search is a good thing. It doesn't quite go away. We leave it behind because we think, oh, today you have smart search. But smart search is never exactly smart. So you usually verify what you found by looking at real search. Well, as I told you last week, I bumped into that. It wasn't quite finding what I needed, and I thought of a brilliant idea. I will do the regular search first. I will find the important documents. But of course, then I'm back to the old primitive search. So no, I thought I will be very smart. I will ask ChatGPT what are important terms in this query. Well, that's not very smart, but I'll do that. And then I will ask my regular search, and then I will ask smart search. Well, it turns out it's a surprise and no invention on my part, because hybrid search is exactly that. They don't explain that. They say it is a combination of sparse vector search and dense vector search, which doesn't tell anybody anything. But what it really means is that it is sparse vector. That is your regular search, and it's called sparse because it has little information. And dense vector search is a semantic search, this one, because it has a lot more information. That is what it is. So if I was to implement my idea, I would look looking very stupid, because hybrid search is there, and the vector database that they use, of course, is Pinecone, because the guy Tim Tully, who is giving us the lecture, he is from Pinecone. So Pinecone allows you to do hybrid search. You can stick all these regular search results in there, and in the same place, you'll put the dense vectors. Okay, that's what they talk about. And then facial similarity. They want to find in this crowd who is the parent of this child. So if they can describe the features as vectors, they are now looking for vectors that are similar in some way. That is possible again with semantic search. So it's similarity search, you can call it this way. And finally, anomaly detection. So you would think, no, anomaly detection, it's not doable this way. Well, the claim is that it is, and they're looking for something that is close. And if you don't find anything close, well, that's an anomaly. That is what the course is about. My personal plan, well, I will download all the notebooks. I will make sure they work. I will go through that, because I found one more thing. And I, again, shamefacedly admit that I didn't know enough, and I would call it stupid. The only justification is that it just came out. But I was fighting with one other problem. When I'm sticking all the vectors into the semantic search, I run out of connections. Somehow Fast API uses hundreds and thousands of connections, and I run out of files. So I invented a trick. I watch how many connections are there. Then when there are too many, 500, I touch a file. Touching a file changes the date. Fast API says, oh, I need to reload, even though there is no code change, and I'm clean. Well, that looks like a hack. And turns out that if I use what they show, and they show a basic operation, which says, here's a bunch of vectors. Don't send one vector at a time. One vector at a time is a bad approach anyway, because that means you're opening connections and closing them all the time. And you hear right away, that's where you made the mistake mark. All right, that's what this was. Now I showed you what the course is about. I will look at your comments. Example of hybrid search comes from Greg. He says, in customer support, you know the product, which is exactly Samsung Galaxy S3222. So if you want to find a sensible answer, you need to combine the search on that exact term, which is rare and unusual. So you need to search, as Greg says here, search over both fuzzy vector and explicit fields. Don't mention answers for other fields. Perfect, right? Thank you, Greg. That's what they say, and that justifies my being wiped out, not knowing that. That's super important. Okay. Very good. Now, I don't see any more comments. Let's see if I need to let anyone in and allow anyone more to talk. I'll Ryan, Sean, Hilda, Ignacio, Gian. So Gian, you got in. Yeah, you sent me a screenshot that shows how it is not working perfectly, but probably it worked now. All right, thank you. So here we are, and that was this. I described what is the course about. Soon you will see it in my repository, and I will offer to teach it, even though I'll talk about teaching. I have a personal story there. Okay, but before we do, Pinecone announced something new, and announcing something new, they essentially repeated. Let's try to get it. Okay, so they talk about that they have new Pinecone API. I looked at it and I didn't see anything dramatically new. It says that they drastically improved developer experience. So I didn't have the time to start using it yet. But what they advertise is serverless indexes. We already use them. Serverless indexes are just the same as regular ones, except that you don't ask for a virtual machine and pay $70 or $80 at least a month for that, but instead you're being charged for the data that you use and for the processing that you use. So that should be cheaper, especially if you run multiple indices and you don't have to start a new machine per application or per index. Of course, then later on, if the load becomes huge, it might make more sense to run a machine all the time, but serverless looks like exactly the thing, and that we already saw. They talk about additional improvements. So what I found interesting is that they decided to enlighten us about what is this semantic search. That is the link, and I thought it will be interesting to look at that. What is similarity search? So we talk about this all the time as if, of course, I know that. And the real truth is that he gives an example. What if somebody looks for shoes, maybe black shoes, or Nike, AF, and so on? Well, people understand that this is the same thing. So what you show him next is another shoe. But search doesn't. Search doesn't get it, especially Nike being also a shoe. Therefore, they explain that concept. The problem is that when you go deep inside exactly how does it work, they shy away and they don't really explain it. They say, oh, you represent each concept, like each shoe, with a vector, and that vector is very long, like 1,500 numbers, and carries a lot of information. This is hand waving. That doesn't explain it. Then they talk about the famous equation that if you convert the king into a vector, and then you subtract a vector corresponding to a man, and then you add a vector corresponding to a woman, what you get is a queen. So we understand king minus man plus a woman is a queen, but the amazing thing is that these vectors that come out of word to vec also understand that. So it seems like it is a projection of meaning into the vector space. Well, if it sounds like that, that's great. For that, you need to train a neural network. It's not that easy, but that's already programmed and you just use it. Then he explains now you want to find similar vectors or not similar vectors, and for that you measure the distance. And there are a few ways of measuring the distance. They are well illustrated here. First of all, cosine. Cosine means what's the angle between the vectors. It should be zero, and then they are the same. And that takes care of the size of the vector. It doesn't matter big or small, but only the direction matters. That's the cosine, and that's the default. You can also do the Euclidean distance between points, or Manhattan distance, which is a good name because you imagine yourself going through Manhattan, and it's not always straight. It has rules and some streets are closed. So he says that's what you can choose. Again, that's not very deep. That doesn't explain to you how exactly it works. And then he talks about performing search, meaning that, oh, here is the blue point that you have and all the red ones that are closed. So I think this article is good enough, and I have put it into our webinar, but it still doesn't explain how Word2Vec works. Still, it's a little bit better, and at least everybody who sees it becomes somewhat familiar and comfortable with that, even if not deeply knowledgeable. Okay, so that was the Pinecone new capabilities and the explanation of what this Pinecone is, which is another vector database or semantic search by meaning. Okay, that's it. That's it for this, and I think we gave it enough interesting information. Now, let's see who said what. Pinecone update, talking about new updates, is right here. Well, thank you, Greg. Let's do this. Let's take that link and let's put it into our webinar here, but not here, because then people think we already talked about this. No, we'll put it here, and that will be the next one. Okay, now I'm going to talk, so I'm closing what we don't need here, and I'm going to talk about this. And I started talking about this last week, but now I prepared something a bit more. Well, for that a bit more, I think that I have the slides just generated. And once in a while, this application crashes, then you wait a little bit and you open it again. And this time it doesn't crash. So I prepared a few slides to talk about this. And I have a big reason for that. But let me first show you what it is about. So that is the latest thing from Google. But before I tell you what is latest thing from Google and how does it go into the complete picture, I will give you the story that led to that. Where we started is that AI is maybe 10 years in the making, and the story starts with the game called Go. So I will first talk about Go, and then about AI playing Go, and then it will turn out that the latest thing, AI thing from Google, is a step beyond. That's why we need to go here. So first we talk about, I wonder if I can show the slides a little bit better. From current slide, yeah, it's a little bit better. So we're talking about AI today, and that's all usually is ChatGPT. That's all AI that there is, and that's all that's interesting. And I am going to teach in 2 weeks from now. I'm going to teach at a company that forbids the use of AI. In fact, it's very dangerous to even mention. Now, it's one of the technical advanced companies, but maybe, my personal opinion, someone on chat.talk just doesn't get it. And so he forbids using it. Well, when I am teaching there, I'm excruciatingly suffering because the only AI that exists to me is ChatGPT, and everything else is just not comparable to that. But that changes. That's a life-giving change that I can now teach, and what I'm adding is this. Therefore, we understand. So we're talking about AGI, and now we can honestly mention that AGI is pretty stupid. Just recently, I wanted to find the quote. The quote was, but thought kills me, that I am not thought. I love it. It's from Shakespeare, and I asked ChatGPT to save 2 seconds on search. I asked where it is from. And it is a sonnet, a beautiful sonnet about how he would fly to his beloved if he were a thought. But the problem is he's a physical body, and thought kills him that he is not thought. And ChatGPT, without any hesitation, ascribed it to Shakespeare, yes, but Falstaff. Falstaff is a wonderful hero. He wasn't in love that way. He couldn't write that sonnet, even though he is on the level of creativity to write it. But in his role, he didn't. So ChatGPT lied shamelessly, outright. And that's only one example of where it falls short. It hallucinates, we know that, but it also is not very smart. It tries not to do any work. Somebody compared AI, this AI, to a student who doesn't really want to do any homework. So he tries to get away without any work if he can. That's what it did. All right. Well, if so, it turns out that there is a place for specific GI where ChatGPT perhaps will never go. And that's where it is. So let us start with specific wonderful systems here. And I'm getting it from the latest book called Maniac by Labatut. That is a Chilean writer who is becoming more and more prominent because he was translated into English. So he was translated, as Falstaff says, out of honesty into English, and that's his first translated book. In that book, he talks mostly about Johnny von Neumann. That's why it's called Maniac. But in the last chapter, to me, completely not related to Johnny von Neumann, even though he says that Johnny is a kind of precursor to AI, he switches to Go. So first fact about Go, and I knew nothing about them, perhaps you don't, that Emperor Yao, legendary Emperor Yao, invented the game of Go to enlighten his son, because his son was a wild beast who was killing everything in sight. That done, we come to the game of Go that was invented, and we meet Lee Sedol, who is the champion, the world champion of his generation. And those guys, they like to, just like in wrestling, they like to say bad things to their opponents. They're not Buddhists. So Lee Sedol is known to say things like, I have no confidence in this game. I mean, not losing it. There's not a chance. He was somehow aggressive game player. That all changes when AI plays, because you can apply human terms like aggressive player, but they don't mean much. So in any case, we have introduced the major characters. Then comes the next major character who is going to beat it. That's Demis Hassabis. So if you know this name, then you know that he is the CEO of DeepMind. But we meet him at 4 when he was looking at how his father, and a long story about his father and mother, but I'm skipping that. He was looking at his father and they were playing chess. So they showed him the moves, and after 2 weeks, nobody could beat him because he was a genius at many things. One of them was chess. So he was a team lead in England. He's from North London. He team lead in the world competition. But he didn't want to be just another genius chess player. So he bought, a wonderful story, bought a computer with his earnings from chess and started working with this computer, created the first AI game that played reverse, and it won against his peers. So that was a great thing, but then he went to Cambridge because you need the degree, and he got in there at 15, but they said, no, you're too young, you have to wait for a year. So he waited for a year, but meanwhile made a few millions. He got hired in a gaming company, created a new game called Theme Park, multi-million-dollar game, and that gave him enough money to pay for all his education years ahead. That's the game. So that's whom we meet. That is the story of competitions. Kasparov was beaten by Deep Blue, but that was a very specific brute force algorithm, and brute force wouldn't work against more involved games. So now comes the next one, Go. Go is 10 to the power of 10 to the power of 10 more complex. And here, Lee Sedol, the world champion, was beaten by the AlphaGo, and even though it was not called AlphaGo, it was called something similar in Deep Blue. Well, Google immediately bought them. So now, well, it wasn't Deep Blue, sorry, it was DeepMind. So immediately Google bought them, and that's part of DeepMind of Google. They created a very interesting approach. What we're interested in is approaches. First, they learned from all the human champions, 3,000 years of literature on that, and then they let it play against itself. There, it creates more and more strategies, and as a result, it can beat even the best humans. But they still learn from humans. So next step, AlphaGo, is where they don't learn from all the games. No previous knowledge, no human input, let it learn how to beat the humans, and it doesn't. So for humans who thought of themselves as something, that's a shocking experience. And a few pages of the Batut's book are spent on them, how they take it. But if you, from the very beginning, don't try to compete, let's say, with the race car, because it's probably faster than you, then it's no surprise. We humans run an Olympics, and the race cars run by themselves. So that aside, comes ChatGPT, creates OpenAI, and takes away all the thunder. And now we're today. Comes Alpha Geometry, published 2 days ago, I think 2 weeks ago, maybe, back from DeepMind, and shows that it can still do something. That is the whole story. I hope you liked it. Let's see. Google publishes an article. The article is in Nature. So let's look at that. Let's look at this article in Nature. Closing all that. Okay, that would work, but I also have it here. Paper in Nature. And the slides I showed you, that's the beginning of the slides. I also have to explain exactly how it works. What was the algorithm? The algorithm is based on neural networks, plus an additional trick of well, I'll have to learn exactly what's added to those neural networks. But what's important is that it starts from the regular neural network, and then it brings specialized geometric reasoning. The end result, as we discussed last week, is that it solves geometry problems, solves in the sense that it gives you the proofs. The same problems are given to humans. Humans compete world over, and this system beats every one of them, except for maybe 0.5% of the world champions. So that is the article. And we don't have the time to go deeper into this, but you can do it. I will be teaching it soon, so I'll give you more slides. We will probably talk about what you can do with the specific AI, not the general purpose AI, which steals all the limelight today. That's the article, and that's where we have to stop. So what I want to do is this. I'm stopping the share. I'm checking that you're all allowed to talk. Yes, and I'm silent for a minute or two so that you can come up with questions.
Have you found any good comparisons between vector databases in terms of accuracy or features of the algorithm?
Yes, that's a good question. We didn't talk about this, but
Yeah.
I found an article that describes all of that.
They said they found some credit issue, so I'm waiting to hear from them.
Now
Was there
that
any eviction,
is,
anything like that recently in court?
I think that is talking somebody who didn't mute his mic.
Yeah, I don't know. So I'm waiting for them.
So one
But it was
second.
finished, but they said, so I don't know. I'll call her back ASAP as soon as I find out, okay?
And I know who that is, but I'm finding a way to mute that. 1 second. No, I cannot find him. All right. Whoever knows that he's talking, oh, there you are. Mute. Okay. So last time we spoke about this, it was here, was the comparison of different databases, and that was the article that compared them. So I apologize that I didn't go in more detail about that, but I'm looking for volunteers. It's right here. It says 5 best vector databases, and then creates a graph. So is that your question?
Yeah, I'll take a look at that. I posted a link that was doing some comparison between a couple of indexes, but this looks like it's a broader comparison. So I'll take a look. Thank you.
It is broader, and it says 5 of the best vector. Well, it may have its drawbacks. It's maybe not perfect, but at least it's the beginning. And if you want to talk about this next time, that will be awesome. Okay, here you are. Now what I'm going to talk about is something in practice right here. Okay, so let me do that. That is my own work. You know, I have this open source product which finds more and more applications. The applications that it finds are like this. It implements both the search and the AI. And it implements that on your documents. It's intended for e-discovery, that is the legal discovery, and it wants to consume millions of documents, and it wants to tell you something about it. But first of all, I'm adding specific reports. For example, if you just talk ChatGPT, maybe I should open that, and it will take me only half a minute to open it, but you will see exactly how it works. So I sign in into my Amazon, and some of these VM instances are already running because I'm giving them out to people. So let's look at Cruise. That's one of my associates. I'm giving to people when I'm giving something to people. I'm giving them a specific link. So what people get is this. They get this interface. So if everything works, you can search. Right now, there are 2 or 3 cases loaded, and each case is a collection of documents. So we can search, and we can see 2339 documents there, and then it's a regular search interface, more or less. But then you can also do AI, and you can ask name the person's name. Okay, just I don't know. Well, but I really want to find something. So, okay, we'll look at one document and then we'll ask questions about that. What do we see? We see some Enron stuff. Well, it's a Bailey. There is a person called Bailey. So let's ask about this Bailey. I know that Susan Bailey is Susan Bailey mentioned. Now it's probably not indexed. Let's try this. Name all the persons here. Okay, I apologize. I don't know what, but the demo doesn't matter. My rule is demos never work anyway. What is important is that you index all of these documents. And right now, I'm giving out these VMs in the read-only mode to anybody who asks for 7 days. Then, if they want to go and look inside, where you have the operator's interface, they would have to go get support. And those who have been to these webinars already know. So I need to give it the password, which I don't give usually to normal people. But inside the normal situation, you see the complete interface, all of that. And that's where you can find out why it's not working, if it is not working. But that's the news. So let me show you what the news are. The news are that I realized that I can already offer to people the read-only VM, the way they can investigate what happened at Enron using AI. That's the read-only demo. And there is more than that. So practically, I'm sending this announcement that you can have the view-only e-discovery, or you can have a more or less complete e-discovery solution. But then it turns out that it works for many applications, like I'm working on the district attorney office implementation, starting from the same approach, and it just changes what documents you use, what indexing you apply. And I'm working on the medical application, and the same thing, you want to know about your documents. So it actually is useful for many, many purposes, as I found out, because what we're doing is learning from the documents and not answering questions. So therefore, what I'm telling people is you have now out of the box solution, even though that's open source, but go and try to build it. It's like Hadoop open source. It is open source, but few people build it. What you get is AI advisor that talks about your documents, and a virtual machine that is all set up, and that's who can use it. And I don't think that many people here on this webinar will be interested, but some might. And then it is a revolution in the sense that well, lawyers have lots of money, so let's charge them. They pay for the data. Let's say they have one drive that they need to investigate, 20 gigabytes, 200 gigabytes, right? So it's $20,000 every month. Even if it is not 20, it is $5,000 to $6,000 every month. Well, that's just because you can't charge that. With this virtual machine, it's you pay for the resources, so it's maybe $100 a month, maybe $200 a month, but it's not 2,000, not 5,000, right? So it's a new model. We'll see what happens to that when it's out, and that's what I wanted to show. Plus, all researchers will appreciate that offer. Hey. So again, I will stop sharing and I'll go silent and I will answer any questions. Okay, and I will check what's on chat. And what we have not checked is from Greg. And okay, that's more, that's an interesting investigation on what is more here, scalable approximate nearest neighbor search. So I promised I will not share and stop talking, but instead I'm looking at the link that Greg gave us. Okay, and I'm clicking on that. So that will be more and deeper view into those same databases, the vector databases. So I think that is something we should look at the next time we meet. So I'm putting it here.
I found it
Yeah.
interesting to read about SCAN because it's one of the algorithms to implement the vector databases. And I was curious on how some of the indexes worked. You know, it's not a B or B plus tree like in a Oracle or relational system. So
Mhm. So good. We need to look a little bit inside if we're comparing vector databases. Now, nothing is perfect. ChatGPT is awesome, but it's not that smart as you would like it to be. And other technologies, even databases, they are, how would I say it? They are not perfect either, right? So you need to know what's the algorithm. All the competing implementations will tell you they're using different algorithm. In truth, they're using something similar, but to make sense out of that, we need to look inside. Is that what you meant?
yes, yeah, I was interested in the internal algorithm. Just like if you're doing predictive models, you might compare on a given data set a XGBoost against a neural net against some other algorithm, you know, to solve that problem on a given data set. So I was wondering if there was comparisons on the algorithms. That's a fuzzy vector database lookup, you know, hash code or whatever, that gets you near the records you're trying to find. But maybe some are doing a better job at getting near the
Yes, some are doing
than
a better
others.
job, right? All algorithms are equal, but some are more equal. So I think we have at least suggested themes to discuss and alpha geometry in more detail. And what I'm mostly doing is simplifying. That seems to be my life. So I'll try to summarize it in a simple way. That is what I've done with the Talmud. You guys all know, but that means that I took 2,711 pages and summarized each one of them in a very short form. Yes, it was a lot of work, but the end result is I'll show you yesterday's page. That was funny because of the art. Okay, so we're talking about if somebody deals a fellow a blow in the ear, that's not nice and he has to pay. But in addition, and that we don't find in the civil court, he has to ask forgiveness. You have not heard, I'm sure, about the court saying, okay, 5 million, and by the way, say, excuse me. But in the Jewish court, it seems that yes, that's the rule. And look, in fact, even in the Bible, you find that there, Abraham, he was wronged, but then he prayed to God and God healed. Only then God healed, and before he didn't. But the illustration that my wife showed here is amazing because she always has a point of view that is different from what the text says. So here it's a prodigal son by Rembrandt, and the idea is that what could be the better parable of somebody wronging somebody and then the somebody else can forgiveness? That's the prodigal son parable, and here it is. Okay, that is just out of the blue. By the way, I was showing you how that works, but I will explain that I like summarizing, and that is what we will do next time, I think. I promise that I will stop, so I stop share, go silent. And if there is no ask, then we have worked enough. We talked for an hour, and I wish everybody a great weekend and a great week coming up, and more than that. And we'll see each other next week. So thank you. Thank you, everyone. Steven, what's the one-line summary on which VectorDB to use the answer Pinecone? And a second line explanation is that because it is out of the box, it has a free option. And now it also has serverless, which means even if it is not free, you only pay for what you use. So in the very beginning, it will work perfectly for you, even the money aspect of it. Okay, I'm not connected to Pinecone in any way. All right, thank you very much, everybody, and be well.